Imagine a world where particles can be in two places at once, and they change behavior just by being observed. Welcome to the realm of quantum physics, a realm where the very foundation of reality as we know it is challenged, a realm where the microscopic and the macroscopic dance in a ballet of existence that defies common sense, yet underpins the very fabric of the universe. In the early 20th century, two of the greatest minds of the era, Niels Bohr and Albert Einstein, embarked on a journey to decipher the mysteries of the universe. They conducted an experiment that would forever alter our understanding of reality. They observed something fascinating, something that classical science could not explain: particles behaving like waves, and waves behaving like particles. This is known as wave-particle duality, a cornerstone of quantum mechanics. But it wasn't just the dual behavior that left them perplexed. It was the strange fact that these particles seemed to know when they were being observed. Yes, you heard it right. These particles seemed to exhibit a form of intelligence. They changed their behavior from particle to wave when they were observed. This was a conclusion that, as scientists, Einstein and Bohr couldn't easily accept. It suggested that the smallest form of light, the photon, was aware of its surroundings. It challenged the very foundation of classical science. Yet, they could not deny the evidence before their eyes. They repeated the experiment, changing every possible variable, even their presence in the room. Yet, the result remained the same. The particles changed their behavior when they were observed. But how can particles act like waves? And why do they change when observed? This is where the mystery deepens. This enigma, this paradox, is what makes quantum reality so fascinating, so baffling, and so undeniably mysterious. This is the world of quantum physics, a world that challenges our understanding of reality, a world that invites us to question, to explore, to unravel the secrets of the universe. Welcome to the enigma of quantum reality. Niels Bohr and Albert Einstein set out to explore this enigma with a series of experiments. Their quest? To understand the dual behavior of particles and waves. What they discovered would forever transform our understanding of reality. They began by observing photon particles, the smallest form of light. As they watched these particles, something extraordinary happened. The photons seemed to realize they were being observed, and in response, they changed their behavior. Instead of acting like particles, they began to behave like waves. This was a revelation that defied logic. It was as if the photons were intelligent, aware of their observers. Yet, such a conclusion was inconceivable. It challenged the very core of classical science, which held that the physical world was objective, independent of the observer. Bohr and Einstein were not easily deterred. They tweaked the experiment, changing every variable they could think of, but the result remained the same. The moment they observed the photons, the particles morphed into waves. In a final attempt to eliminate any unknown factors, they decided to remove themselves from the test room. They set up a camera to record the experiment, leaving the photons alone with the cold, impersonal eye of the lens. Yet, even then, the photons changed their behavior when observed. The implications of these findings were staggering. The smallest form of light, it seemed, was not only aware of being observed, but could also change its nature in response. This astonishing discovery sent shockwaves through the scientific community, shaking the very foundations of classical science. This behavior of photons, this strange interplay of observation and transformation, was named the observer effect. It became a cornerstone of quantum physics, challenging our understanding of the physical world and setting the stage for a new era of scientific discovery. These findings were so extraordinary that they shook the foundations of classical science. This was the experiment that shocked science, and it forever changed how we view the world around us. This strange phenomenon came to be known as the observer effect. This term may sound like it's straight out of a science fiction novel, but it's actually one of the most intriguing concepts in the world of quantum physics. In essence, the observer effect suggests that the mere act of observing can alter the state of what is being observed. It's as if the particles, or in this case the photons, are aware they're being observed and change their behavior accordingly. It's a concept that turns classical science on its head, challenging our understanding of reality itself. This isn't about a simple change in behavior like a shy person acting differently when they know they're being watched. We're talking about particles of light, which we don't typically associate with awareness or consciousness. Yet these particles, these infinitesimal components of our universe, seem to change from behaving like particles to behaving like waves when they're observed. This isn't just peculiar, it's downright baffling. This enigma didn't just add another layer of complexity to our understanding of the universe, it altered the course of modern physics and quantum science. It forced scientists to rethink the fundamental nature of reality itself. It's a concept so profound that its implications are still being explored and understood even today. The observer effect suggests that even the smallest components of light are aware of their surroundings. But how can this be? Are these particles actually intelligent entities capable of changing their behavior? Or are we, the observers, somehow influencing their state with our observation? These questions have sparked countless debates and have led to some of the most fascinating theories in quantum physics. What we do know is that the observer effect is real. It's been tested, verified, and it continues to baffle the brightest minds in science. But as to why or how it happens, well, that still remains one of the greatest mysteries of our universe. The observer effect suggests that even the smallest components of light are aware of their surroundings. But how can this be? Scene script. Let's take a journey from the Sun to the distant planet of Uranus. Imagine a beam of sunlight, a stream of photons making its way across the vast cosmos. The journey from our star to the distant planet of Uranus is an impressive one, taking about 3 hours at the speed of light. But within this beam of light, there lies a mystery that perplexes the greatest minds in physics, the phenomenon of quantum entanglement. Picture one photon from this beam being observed here on Earth. According to quantum theory, the very act of observation changes the photon's behavior. But here's where it gets truly mind-boggling. The moment we observe this photon, another photon, perhaps one near Uranus, if entangled with our Earth-bound photon, will instantaneously change its behavior too. This happens regardless of the vast distance between them. No signal, no interaction, just an instantaneous, inexplicable connection. This is quantum entanglement, a phenomenon so strange that even Einstein referred to it as spooky action at a distance. It defies our everyday understanding of the universe, suggesting that the very fabric of reality is interconnected in ways we are only beginning to grasp. The implications of this are profound. It suggests that the universe, at its most fundamental level, is not a collection of separate, isolated objects, but a web of interconnected phenomena. It hints at a world where distance is irrelevant, where the behavior of particles can be synchronized across cosmic scales in the blink of an eye. But what makes these particles change their behavior? Is it because they possess some form of intelligence, as Bohr and Einstein initially pondered? Or is it us, the observers, who somehow alter their fate with our gaze? Quantum entanglement and the observer effect challenge the very foundations of our understanding of the universe. They throw open the doors to a world that is far more mysterious, far more interconnected and far more fascinating than we could ever have imagined. So what does this tell us? That distance is no issue for these particles, a startling realization indeed. To understand this better, let's visit Schrödinger's infamous cat. Picture a cat enclosed in a box with a radioactive atom that could, at any moment, emit a particle, triggering a sequence of events that would end the cat's life. Until we peek inside, the cat is both alive and dead, a twilight state known as superposition. This isn't because we don't know what's happening inside the box, but because the cat's fate is entwined with the quantum world, a place of probabilities. When we do finally open the box, we force nature's hand. The cat must be either alive or dead, not both. The act of observation collapses the superposition into one outcome. This is the power of the observer in the quantum realm, an influence that shapes reality itself. So, is it the observer that manifests reality? Or do particles indeed possess some form of intelligence? The mystery of quantum physics continues to baffle us. The observer effect, this curious phenomenon where particles seemingly switch their behavior when watched, has been at the heart of our exploration today. It's a concept that has shaken the very foundations of classical science and continues to challenge our understanding of reality. Two interpretations emerge from this enigma. One, that the tiniest particles of light are imbued with an intelligence, a consciousness that allows them to sense when they are being observed and subsequently alter their behavior. Alternatively, it could be that we as observers are the ones influencing these particles, our gaze directing their fate. The example of Schrödinger's cat, existing in a state of both life and death until observed, further illustrates this conundrum. It's a paradox that suggests that nothing and everything exists simultaneously until the moment of observation. In the end, we are left with a tantalizing question. Does reality exist without observation, or does our gaze shape the universe? Perhaps the answer lies in the heart of quantum entanglement itself.
Subscribe to the channel for more video, and please give us a thumbs up if you enjoyed this.